Good morning, students. Today's topic to be discussed is algebraic factorization. This topic could be beneficial for different grades. Usually we start algebra in schools at grade 6, but this topic, algebraic factorization, that could be helpful for higher levels as well, like for metric stream and for O levels as well. So I'll be guiding you about basics of this topic. Let's see the objective: to do algebraic factorization. I will start here with the small example, and let me show you this in small screen. Yes, so here it is written that if someone asks you what are the factors of 20, so you need to understand what is the meaning of factor. Factor is or I can say factors are those numbers which can divide a number completely with no remainder left at the end. So if someone is asking what are the factors of 20, so simply the thing that comes in your mind is you will try to write those numbers which divides 20 completely with no remainder left at the end. And if you see the list of those numbers, these are those numbers: 1, 2, 4, 5, 10 and 20. So this is the complete list of all the factors of 20. Now how this is justified, like 1 20 times is 20, 2 10 times is 20, 4 5 times is 20, 5 4 times and 20, 10 2 times 20 and 20 1 time 20. So the thing that is important, like you need to know first that what are the factors of a number. So in that way you can write all the factors of any number. To add it one more thing, that whatever the number you are to write the factors, the limit is starting from 1 and it ends with that number for what you are to calculate the factors. Like if you are to write factors of all factors of 20, the range is 1 to 20. Factors of 25, so without looking at the answer, the first thing that comes in your mind need to be that the smallest factor is 1 and the largest factor is 25, and these are all the factors. Only 1, 5 and 25 are the factors of 25. Third example, factors of 30. So as I told you, the range is from 1 to 30. All the factors will be coming within this range. No factor of 30 will be exceeding 30. That is the number itself. And you can see 130 times 2, 15 times and so on. So these are all the factors of 30. So I hope with this example you people have understood what is the meaning of factors of a number. Now let's move forward. Here there is a definition of factors. I hope it's visible to all of you. Factors are those numbers which completely divides a number with no remainder left. So what it means? It means if any number we are dividing with, but the answer is coming within decimal places, or maybe if coming in a whole number there is a remainder left after division, then that number will be no longer a factor of that number. For any number to be a factor of any particular number, that need to divide it completely with no remainder left. So this is the definition of factor. There is an example of numeric factors. What is the meaning of numeric factors? If someone asks you that write factors of 15, so here you can see few pairs are being written in product form: 1 multiplied by 15, 1 15 times 15, then 3 5 times 15. So in that way we usually write the factors. So in this way 1 15 3 and 5, these are all the factors of 15, starting from smaller to larger number: 1 3 5 and 15. These are all the factors of 15. So here you can see if we are to write factors of 15, so 1 and 15 are the numeric factors of 15. Why we are calling them numeric? Because these are the numbers. There is no algebraic term being used here. So whenever any number is being written in a product of two different factors, those are called numeric factors. 3 multiplied by 5, this is also numeric factors are being shown for 15. So 1, 3, 5 and 15 are numeric factors of 15. Then there is another example of algebraic factors. The first example was for numeric factors. Now we will see example of algebraic factors. Whenever algebraic terms are being used or any algebraic expression. Now if you see this highlighted expression, this is expression 2x plus 4y minus 6. And what tells us that this is an algebraic expression? That over here you can see some variables, they are x and y. Then you see 2 is a coefficient of x, 4 is coefficient of y, and minus 6 is a constant. So obviously we know that if any such like expression is written, so here algebra is being involved here. So keeping in mind how we wrote the factors of 15, if we are being asked to write this expression in its factor form, or we are to show this expression in factors form, so what we will do, we will try to write it in product of two different factors. So the first method here is that you are to look for if anything is common in this whole expression, take that number common out. So if you see this expression, no variable is common, but 2 is the common element. So you will take 2 common out, and whatever is remaining, you can see x is left here, 2y is left with this term, and minus 3 is left. When 2 is taken common out, if you want to recheck how this 2 is being taken common out, you can see just multiply the number 2 within all the whole of the bracket, or you can say multiply 2 with each term of this bracket. 2 multiplied with the first element, it gives you 2x back. 2 multiplied with 2y, it gives you 4y back, and 2 multiplied with minus 3 gives you a minus 6 back. So you will write the coefficient of the variable here in its factor form. Like here you can write 1 multiplied by 2, 1 into 2. 4 could be written as 2 into 2, and 6 could be written as 2 into 3. Then 2 is common in whole this expression, that is taken out. So this is the way how we usually write algebraic factors of any algebraic expression. We'll work more on this. Now here see what it is, factorization inverse of expansion. This concept is very important, which need to be understood, and I would like to explain it to all of you. Usually students keep on doing the work, but they don't know the exact meaning of the mathematical terms. I am working on factorization, and see what is written here, inverse of expansion. Whenever you will be doing factorization of any algebraic expression, it is actually inverse of expansion. I will guide you shortly both the terms, that what is the meaning of expansion and how it is factorization is inverse of expansion. So previously we worked with expanding algebraic expression. If you see this example, you people have been doing such work, like if you see the highlighted expression, 3 is written outside and there is a bracket in this way, 4a minus 2b plus c. So the question to do is sometime like expand it. The term expansion is being used in the question. So what you are being asked, that expanding this type of expression mean you are to multiply 3 with all the elements of the expression. So you will just quickly multiply 3 with coefficient 4, 3 with minus 2 and 3 with 1c. In result you will get this expression. So this process, while opening the bracket, and if any constant is written, any variable is written, you are being multiplying it with each element and you are getting this answer. So this method is called expansion or expanding something. Now how factorization is inverse of expansion, that is to be understood. Here we convert an expression into a product of its factors. So as if you see the previous example, let me show you this one. When 15 was there, how we wrote its factor? 1 multiplied by 15. Like we chose two of its factors and we multiplied it. So multiplication, for this one another name is product. So whenever two factors are written in product form, that is called factorization of that number. So here, while doing the algebraic factorization, here you can see this one is the algebraic expression given, 3xy plus yz minus 6y. And whenever we are being asked that do the factorization, so as I told you that you will look for anything common in whole of the expression. Here you can see, if you see 3 is here, here there is no number written, it means there is a 1, and this is minus 6. So the number, no number is being common in three of them. And if you will see the variable, here it is xy, this is yz, and this is minus y. So yes, it's very clear that y is the common element in whole this expression. So you will take y common out. While taking it common out, obviously when one y is taken, so what's left in this first expression? Only 3x is left, that will be written. Here you can see z is written, z is left, and then last minus 6 is left. So here you can see when this way the expression is being written, this is called factorization. And if you see this example, we have actually converted this expression into this form. Here when this form was given, factorized form was given, we expanded it and we wrote the expression this way. Now this is inverse. While doing factorization, it is the inverse of expansion. This was the expression. If you just match it with this one, this is exactly the same way this expression was written here. So to convert it into factorization, we are actually doing what? This is inverse. So both of them, I hope this concept is clear to you. Expansion, multiplying the number with each term of the bracket, we have expanded it and we got this one. And when this type of expression is given and we are converting it into product of its two factors, that is called factorization. So they both are inverse of each other. Let's move forward now. Now there are different methods of factorization. I will guide you two of these methods, which are basic two methods, and in higher levels, in metric grade or O levels, there are different other methods as well, but I am just taking here the first two common methods. The first method is taking common out, and the second method is regrouping. Now let me shortly explain which we have done in the previous examples as well. In taking common out, the common factors are taken common out. This is the example. I have shortly described you in the previous example, and if I will ask you to help me out doing this one, so let's see. I would like you to do it mentally in your mind as well. Give it a few seconds to think of that what is being common in this whole expression. 7x, 14y and 21z. So you can see that 14 is a multiple of 7, 21 is a multiple of 7. So we can take out 7 common out, and if you see the variables, here it is only x, only y and only z. So there is nothing common in the variable side. So let's take 7 common, and what's left? X is left. Then in the second term, here 7 how much time is 14? 7 2 times is 14. So 2 will be remaining and y will be written along. Then next sign is positive. Now see 7 how much time is 21? It is 3 times, so you will write 3 along with z. Z will be multiplied with it and then close the bracket. Yes, so here by taking 7 common out, this is done. This is our answer. This is the first method. We have done the factorization. 7x minus 14y plus 21z was given. Taking common out 7 and writing it as product of factors. 7 is one of the factors and the other factor is x minus 2y plus 3z. And always remember that bracket represent product of something, multiplication. So yes, this is justifying the definition of factorization, that this is product of 7 and this whole algebraic expression. Now see these other two examples here. This example 2, taking algebraic factor common. This is again the first method. Here the expression is this one, xy minus 2y square plus y cube z. This is the expression given and we are to do its algebraic factorization. So keeping in mind the first method, that is taking common out, we'll be doing this example. So look for what is common in this whole expression. Do this work in your mind as well. Here it is xy, 2y square, y cube. So if you notice, y, when there is no power there, it means there is a power 1 there. X power 1, y power 1. If you see the common elements, y power 1 is present in this one, y power 2 is here and y3. So what is common in 3 of them and with the highest power and which is present in 3 of these terms? So if you see y power 1, it is present in this one, y power 1 is also present in y square and y power 1 is present in y cube as well. We will not choose the highest power, but we will try to choose that power of y which is highest and present in 3 of them. If you choose y cube, it is present in this one but not in y square and y1. If you choose y square, it is present in this one but not in the first and the last one. In last one it is there, y square is there, but it's not present in the first term. So we will try to choose that power of the variable which is in 3 of them. So here y power 1 is present in 3 of them. Let me show you this. So we will take out y common. What's left? X in the first term, 2 y in the second term and y square is there. Let me show you its power. We need to insert equation while working on a computer here. So this way you will show y power 2 and finally we will put the bracket closed. So this is done. This is answer for this expression, y taken common out and x minus 2y plus y square, z was also to be written here. Z will also come because it is not being taken common out. So this is answer for this algebraic expression. Now in example 3, I will show you the second method, that is regrouping. As I told you earlier that there are basically two methods which I am going to explain you today. So right now I am going to explain you the second method, what is regrouping. So whenever any expression is given to you, see this highlighted expression. Firstly, we will always try to apply the first method, that does taking common out, is it working here, does it work here? If it is not working, then you will look for the other method. So here if you see in xy minus z plus xyz minus z square, nothing is there which is common element in all of them. unless 1 is a coefficient which is present in all of them, but it will be of no use. If we will take 1 common out, then there will be no change in this expression. So first method will not work here. We will apply the second method, that is regrouping. So what is regrouping? Basically, you are to rearrange these elements within expression to take common out. Taking common out is also involved in it, but you are to regroup these terms together. So if you see the first two terms, x, y minus z, you can see that basically you are to make groups here. If we make these first two terms a group, you are to see whether something is common in both of them. So if you see the variables, there is nothing common. Similarly, so what we will do, if there is nothing common in both of them, you can group this xy with the third term. Try to look for something common in first and third term. Even if you think so that there is nothing common still, so you can group it with the last term. But here you can see xy and xyz, yes, we can group them together. So I am writing xy plus xyz. Yes, I have grouped first and third term together, and then minus z minus z square. Let me copy paste it here. So in that way we will regroup the terms. Now see that after regrouping, in first two terms, what is common? Here you can see xy is common in both of them. So xy we will write out. Then in bracket, what will come? From both these terms, we are to take xy common. So in this first term, only 1 is left, and in the second term, z will be left. So in that way, whatever is common out, you have taken common out of these first two terms. Done. Now out of the remaining two terms, you will look for something common and take it common out. So from the second group, you can see a negative sign is common in both of them. And if you see the powers of z, here it is z power 1, and in second one it is z power 2. Z power 1 is common in both of them. So I'll take z common out. Now what's left? 1 plus z is left inside, and we will close the bracket. Now here the important thing is that negative sign is also taken common out, because it was present in both of them. We took minus z common, and 1 plus z is remaining. And the last step to do here is, after which this factorization will be completed. The last step is very easy. You see 1 plus z and 1 plus c. This is present in both these two groups. So, and you can, the important thing to understand is that 1 plus z will be same as compared to the second term. The terms within the bracket will be same, 1 plus z, 1 plus c. This is a sign as well that your factorization is working fine. It's doing fine, and you are working well. So the last step is to write the common factor. Here 1 plus z is present in this term and in this term both. We will take it common out. 1 plus z, we are taking it out, and then let's draw the second bracket. See here, what is the uncommon factor? xy, and then this one minus z is the next uncommon factor, minus z, and then close the bracket. So this is our final answer here. Again I am repeating it. 1 plus z was the common factor. Let's write it one time, take it common out. Here what was left? Xy, write it here, and minus z is left here, write it here. So in that way you can see this whole expression is written in one bracket and the other expression is written in the second bracket. And as I explained you earlier, that brackets mean to multiply, it's a product being shown. So our target has been achieved. By regrouping, we have converted this algebraic expression into product of its algebraic factors. This is done, and I hope you people have understood. It's not difficult, it's very easy. With practice this concept gets very well. And there is a last example here again, regrouping again. So if let's do this example as well. Here 3x minus yz minus 3z plus xy. If I ask you, let's apply the first method, that is taking common out in whole of this expression, it will not work here because there is no element that is common in all of them. So we will do regrouping, like grouping first two elements together or the last two terms together. If it is not happening, still nothing is common, then you can group 3x with 3z, or you can group 3x with xy. Here 3x will be grouped with, it could be grouped with minus 3z. I am grouping first one with the third term, and then minus yz with the last term. Fine. In that way these elements are being grouped, and let's see. Now the first method is being used in the first two terms. Take common out, 3 is out, x minus z, close the bracket, and then try to look for what is present common in these two terms. Here you can see y is common in both of them, and as I told you earlier, that whatever number or element you are taking common out, the term within the bracket need to be same if your factorization is happening right. So I will take plus y common out, and what's remaining here in this expression, in this term, minus z is left, and in this second term x is left, plus x is left, close the bracket. So in that way, what is the difference here? This one was supposed to be the same as this second bracket. Here it is x minus z, and here it is minus z plus x. But it's not a big problem, it's just a matter of arrangement. If you write minus z at second place and x at first place, it will not affect the answer. So down here, if you will write it this way, it will not affect the working. So here you can see x minus z is same in both of them. Take the common out, and what's the remaining, what are the uncommon factors or remaining elements? 3, and from here it is plus y. So 3 plus y, and close the bracket. So this is done. This is the product form. We have done the factorization. This was the second method of factorization. I hope this basic concept of algebraic factorization is being understood by all of you. If you have any questions, you can ask me in the comment portion, and if you want me to make any video on the further methods of factorization which are next to these two methods, I can also make, but do mention it in the comment section. And thank you so much. That's it. And if you see our target of today's lesson that has been achieved. That was to do algebraic factorization. And if I wrap up the session, we did two basic methods of algebraic factorization, starting with the meaning of factorization, discussing the numeric factors of a number. Then we discussed algebraic factors of a number and how to factorize an algebraic expression. We did two methods. First one was taking common out. If nothing is common out, then go ahead for the second method, that is regrouping. That's it. Thank you so much. See you again. Allah Hafiz.